All right, back to finish up this chapter 6, lesson 1, solstices, equinoxes, and the seasonal cycles. As Earth travels around the sun, Earth's rotation axis always points in the same direction in space. Let's go ahead and highlight that. But the amount that Earth's rotation axis is toward or away from the sun changes. This causes the yearly cycle of the seasons. There are 4 days each year when the direction of Earth's axis is special relative to the sun. So I'm going to change this highlighter to yellow because this is one of our vocab words. A solstice is a day when Earth's rotation axis is the most toward or away from the sun. An equinox is a day when Earth's rotation axis is leaning along Earth's orbit, neither toward or away from the sun. So we're going to want to make sure that we add these 2 vocab words to our assignment. March equinox to June equinox. So we'll get into that in just a moment as far as when those dates are. March equinox to June equinox. The north end of the rotation axis slowly points more and more toward the sun. And we know that because we know that in the spring going up to summer, it gets warmer and warmer and warmer. As a result, the northern hemisphere slowly receives more solar energy. Spring takes place in the northern hemisphere. June solstice to September equinox. So the north end of the rotation axis still points toward the sun, but does so less and less. The northern hemisphere starts to receive less solar energy. This is summer in the northern hemisphere. So then we get to the September equinox to December solstice. The north end of the rotation axis points more and more away from the sun. The northern hemisphere receives less and less solar energy. Fall takes place in the northern hemisphere. Then we have December solstice to March equinox. The north end of the rotation axis still points away from the sun, but does so less and less. So we're going from the solstice and then we're entering where we're going to be having more and more daylight hours, which is what's happening now for us. As a result, the northern hemisphere starts to receive more solar energy. This is winter in the northern hemisphere. Earth's seasonal cycle is summarized in the table on the next page. All right, so this is what we're going to take a look at. So our December solstice, it happens around the 21st or 22nd, and the north end of Earth's axis is leaning the farthest away from the sun. The south end is closest. So we're just really looking at the northern hemisphere. At this point for our December solstice, it's going to be the fewest daylight hours. That's when a day, it's dark like at 4:30, 4:45. We've got about 9 hours of daylight only. That would be in the northern hemisphere. Now the southern hemisphere, they're most toward. So they would be getting a lot of sunlight. The southern hemisphere has its greatest number of daylight hours and summer begins. Remember, the seasons are opposite. So if it is winter in the northern hemisphere, then it is in the southern hemisphere, it is summer. All right, so then we get to, let's choose a different color. Let's still choose a different color. There we go. How about that one? March equinox. So that about 3 months later, we are March 20th or 21st. So that's what's going to happen for us soon. We're going to be starting to look at our daylight hours and how the daylight hours are slowly increasing. Both ends of Earth's rotation axis are equal distance from the sun. So that's where our equinox goes. There are 12 hours of daylight and 12 hours of night. So that equinox, I want you to think of equal. So equal day, equal night. Versus a December solstice is definitely not equal. We have the shortest amount of daylight hours and the longest number of nighttime hours. Spring begins in the northern hemisphere and fall begins in the southern hemisphere. So this word here is also known as vernal. Vernal means spring. Okay, so then we're going to come down to the June solstice. The June solstice is on June 20th or 21st. This is also known as the summer solstice. And so I bet you could guess that this is also known as the winter solstice. All right, so the north end of the Earth's axis is leaning closest to the sun, and the south end is farthest away. The northern hemisphere has the greatest number of daylight hours, and summer begins. The southern hemisphere has the fewest number of daylight hours, and winter begins. Whatever is happening in the northern hemisphere is going to be completely opposite in the southern hemisphere. Okay, so let's come down to our final one. So let's choose green for September equinox. That is also known as the autumnal. So you can see the word I'm going to have to erase that because that did not end up very well, did it? Okay, so that autumnal. A-U-T. So you can see the word autumn in there. And that's what we're looking at. Okay, so it happens between September 22nd and 23rd. Both ends of the Earth's rotation axis are equal distance. So remember, equinox is equal. There are about 12 hours of daylight and 12 hours of night. Fall begins in the northern hemisphere, and then spring begins in the southern hemisphere. So I will be showing this when we are in person and we are being able to look at all of this with a globe. All right, so it's going to make a lot more sense to you. Okay, last little section here. Changes in the sun's apparent path across the sky. Now remember, apparent. We've talked about that before, that apparent means just our perception. The sun is not actually moving across the sky. It is the Earth's rotation from west to east counterclockwise that makes everything in the sky appear to be moving. So as the seasons change, the sun's apparent path across the sky also changes. In the northern hemisphere, the sun's path through the sky is highest on the June solstice and lowest across the sky on the December solstice. So it's highest when we're on the day when we're most pointed toward. The sun will appear highest in the sky. And then on the December solstice, so 6 months later, when we're most pointed away, the sun is going to appear lowest on the horizon. All right, so then there are your vocab words for this particular chapter. So let's take a look at your notebook and let's get this filled in. So the first here is having a definition. So solstice and equinox. So it's just right from the book. Day when Earth's axis is the most toward or away from the sun. So that's going to be June solstice is going to be when we're most toward, and our December or winter solstice is going to be when we're most away. So then our equinoxes is a day when Earth's rotation is leaning along Earth's orbit, neither toward nor away. So that's where we're going to have equal number of hours, daylight, nighttime hours. So we see the word equal in here. Equal, okay, EQU. So if we can just keep that straight in our head, that when we have an equinox, we have equal day and night. So we have two of those. We have the vernal equinox, which is in the spring, and the autumnal equinox, that's in the fall. So then let's come down, and guys, at any point here, you just need to pause this video and get things filled in and then restart. So we have this little chart where we would be filling in the dates and the seasons. So the December solstice would be December 21st or 22nd is the start of winter. And March 20th or 21st is start of spring. June 20th or 21st, start of summer. And September equinox, September 20th or 21st would be fall. So we have a solstice, an equinox, another solstice, and then an equinox. So every 6 months we have a solstice, and every 6 months we have an equinox. So really there is a special day every 3 months. So what's happening with that, with the amount of solar energy received, when we're at that December solstice, we're the most tilted away. So we're making that orbit, that path back around. So we're going to start to receive more solar energy. So then we're about halfway, like 3 more months, and we're still increasing the amount of daylight hours that we're seeing. We're seeing that happening right now. So we're increasing until we get to that June solstice, which is the longest daylight day of the year. So then we make our swing back around. We're continuing on this elliptical, this orbit. So once we have our longest daylight, solar energy daylight day, then as we are moving from June down to September, we're going to be decreasing the amount of daylight hours until we hit that equinox where we're half and half again, 12 and 12, and then we're going to decrease until we get to the winter solstice, the December solstice, and then we're going to be increasing until we'll get to the summer solstice, and then we decrease until we get to the winter solstice. So the shortest daylight day would be our December solstice. Our longest daylight day would be our June solstice. So our shortest daylight day, we get about 9 hours of daylight. Gets dark right about 5 o'clock. Our longest daylight days, we're around 16 hours, and so it's light until like 9:30, right? So great, that's great for summer. So then, what does it look like? The where the sun appears on these days. So since we're most tilted away during the December solstice, the sun is going to appear lower on the horizon. It's going to be lowest across the sky. And the June solstice is going to be highest across the sky. So our synthesized question says, suppose that Earth's axis were tilted 90 degrees instead of 23.5 degrees. What might the seasons be like? Well, if there's no tilt, or really in this case, we have a 90-degree tilt, then the seasons would not change. You would have that season the whole entire year. So if there's no tilt, or if it's any kind of 90-degree tilt, then we would have no change in our seasons. A couple of things I want you to make sure that you add on your notes here is that gravity depends on the mass of the object and the distance between them. We've talked about that quite a few times now, but I just want to have you have this in your notebook so that when you go to study for your test or filling things in for your study guide, you'll have it in your notes. So then gravity and inertia keep Earth in orbit around the sun. So I just want you to get both of those things written here. So I'll go ahead and scoot this back so that you can see all of this. Once again, if you need to stop this video to write a few things down and then start it, write a few things down, and you go ahead and do that. All right? Okay, talk with you soon.